All right, 17.2. Now we're going to talk about similar figures. We talked about congruent before. Now we're going to talk about similar. Use kind of the same types of rules with similar triangles or polygons in general. If they're similar, let's start with the notes. They have the same shape, but different size. Okay? So two polygons are similar, okay, not congruent, similar if they're the same shape, triangle, rectangle, whatever, but they're different size. Okay? Polygons are similar if their corresponding angles are congruent. Okay? Now here's the difference. The corresponding sides are proportional. Okay, what does proportional mean? Well, we just did that assignment on 17.1 about proportions, where you can set up a ratio and comparing the sides. So side of one triangle compared to the same side of the other triangle, so on. Those fractions would equal each other. We're going to talk about that. Okay, let's see. Now the ratio of the corresponding sides is called the scale factor. So the scale factor, if you have one side of one triangle is 2 and the same corresponding side in the other triangle is 6, your scale factor is 1/3. 2 to 6, or reduce the fraction 1 to 3. Okay, according to the way you were writing those two triangles together. If the polygons are similar, then their perimeters are also proportional. So if you had the perimeter of one triangle, you could set that as a fraction over the perimeter of the other triangle. Okay, now let's go on to scale factor. What is scale factor? Well, scale factor is just that ratio from one figure to the next, or one side of one to the same corresponding side of the other. So now notice how this is written. Triangle ABC to DEF. So your scale factor is going to be from triangle ABC to DEF. If it was written the other way, like on the second question, then it would be written DEF compared to ABC. Okay, so it's important the way it's written, the way you write it down as far as the scale factor, because if it was 1 to 3, you could be 1/3 or 3 to 1. It's just, that's a big difference between the two different scale factors. One is larger, one's smaller in scale. All right, so let's look at, order matters here. So let's look at our two triangles. What is the scale factor? Well, we could match up the sides. So notice how the triangles are marked with their angles. So this side here, A to B, is going to match up with D to E. Just like our statement, A to B matches with D to E. Okay, so AB over 12, or 8 over 12, because it's A, triangle ABC, over DEF. So it would be 8 over 12. What is 8 over 12? That reduces to 4 over, divide by 4. So it would be 2 over 3. Now we could make sure that it's the same for all sides, like 10 over 15. Does that reduce to 2 over 3? We could have done that, 10 over 15. And 14 over 21. Do those all reduce to 2 over 3? 5 divides into those, 7 divides into those. Yes, they all reduce to 2 over 3. Okay? So all three of those ratios reduce to 2 over 3. Now, on this triangle down here, well, we could also compare the perimeters, like up here in our notes, the perimeters. So the perimeter of this one, 8 plus 10 plus 14, that's 24 plus 8, what is that? 24 plus 8, 32. And the perimeter here would be 21 plus 15 is 36, plus 12, 36, 48. Does that reduce to 2 over 3? Well, those all reduce, let's see. What goes into 32? 16? What goes into 16 going to 48? Yes, so 16 goes into 32 twice, 16 goes into 48 3 times. Yeah, so the perimeters have the same ratio as the sides. Okay. Now, what's the scale factor from DEF to ABC? Well, you just go the other way around. So it'll be 3 over 2. We did all that work on the other end, the other direction, ABC to DEF, so we just flip it. What's the ratio of the perimeters, DEF to ABC? So bigger to smaller. Well, it's just 3 over 2, the same as any of the sides. Ratios are the same. Okay, so a similarity statement. Okay, a statement means triangle such and such, congruent or similar to triangle such and such. So when you write the statement, you're going to use the symbol of similarity, which is a little squiggly. Okay, so I'll show you. A valid similarity statement would say, and you want to make sure that you write it in the way that the ratio, the same way the ratio would go. So in this case, ABC to DEF. So a valid similarity statement must match corresponding angles and sides. Write a similarity statement for the triangles above. So if we said triangle ABC, and we use the squiggly, similar to triangle DEF, okay, that's how we wrote the first one. Like the ratios, if we said the scale factor was 2 to 3, then we'd have to go from ABC to DEF. And we could write it the other way if we were doing, if we were saying the scale factor was 3 to 2, then we'd have to write the similarity statement the other direction, DEF similar to ABC. Okay, so that's a similarity statement. All right. Not a congruent statement. These are similar. All right, example 1. So it says list all congruent angles. So if the two triangles are similar, we know that the angles are congruent, but the sides are proportions. Okay, so list all congruent angles and write a proportion that relates the congruent sides. So let's write down the congruent angles. So angle J would be congruent to angle P. Angle K, so the second one, would be congruent to angle M. And angle L would be congruent to angle N. Just match up the angles according to the statement. Match up the angles. So J and P, K and M, and L and N. And you notice they don't have to be, the triangles aren't written or drawn in the same direction. So the proportions, well, let's match up the sides. So J to K would match up with P to M. According to the statement, JK and PM. So we'd say JK over PM. So those sides would equal the other sides, since we're starting with the smaller triangle and going to the bigger triangle. So say KL then would be MN, so KL over MN. And the other one would be what? JL over PN. JL over PN. Okay, so we set up those. Those would be the proportions that we could set up. Now, if you compare any two of them, then you could solve by using the cross product like we did in the last lesson. Okay, example 2. So here we have some values. Let's see what we have. It says if triangle AGM is similar to KXD. So this triangle here on the left is similar to the triangle on the right. So let's match up. We want to find the value of x. We want to match up what sides, because that looks like that's what we have, are the sides. Let's match up the sides so we know how to set up our proportions to solve. So let's see. AG would be similar or proportionate to KX. So AG and KX. Okay, so if we're setting it up, we would say 32 over x plus 3 would equal, and then let's see, GM, so GM would be these two, GM would have to go with XD, GM with XD. Okay, so 36 would match up with x plus 6. Okay, we have to make sure that make sure that that matches up, because if it doesn't, then we'd have to figure out another way to find the other side that matches with these so we could solve them. But for now, it's pretty straightforward. So now we cross multiply. 32 times x, we'll just go this direction. 32 times x is, we'll set it up, 32x. And 32 times 6, that's 192. That's going to equal the other direction. 32 times x is 36 times x is 36x. And 36 times 3 is 108. Okay, so now we're going to, let's see, subtract. We'll subtract 32x. That's going to leave me, I'll just start writing it over here. That's going to leave me 4x. Over here. So subtract 32x. So that's 4x. And then I'm going to subtract 108. So that's going to be 4x to equal 192 minus 108. So 192 minus 108 is 84. And then divide by 4. So x would equal 21. And that's what we're looking for since it said solve for x. Okay? All right, let's see. Now on your assignment, read the instructions. So number 1 is going to say list all the congruent angles and then write proportions for the sides. So you can look at the example we just barely did for that. Now note, they're not all triangles, but similarity doesn't have to be triangles. You can still match up sides and angles. Okay. You can still write the scale factor. Okay. We will deal mainly with triangles, but just so you know, other figures can be similar as well. And give the scale factor. Notice which direction it's telling you to give the scale factor, from triangle A to triangle B. Okay? And it gives you a scale factor on 5 here. Okay? It gives you 4 to 5 going from A to B. So you should be able to set that up like that would be a fraction, 4 over 5. That's how you would start. And then number 7 is solving. And on these questions, these are a little, you just match up, look at the statement, set up the proportion, and solve. Okay? So on number 9, triangle ABC, so the big outside triangle with the smaller inside triangle. So the whole side A to B, you'd have to add those together to get that whole side, 28, and so on. So just kind of see how those go, and enjoy your time. And then we'll start 17.3 in the next video.